Most advancements in electrophysiology technology are small and incremental, but the experts at Texas Cardiac Arrhythmia Institute in Austin, Texas, were quick to see distinct advantages when they started using the latest iteration of radiofrequency ablation, the Q-dot microcatheter. The system combines all of the major advances from the past 20 years, plus new features such as microelectrodes and more accurate temperature sensors embedded into the tip. Some in the EP field have called this the pinnacle of RF technology. The thermocouple in the tip helps improve safety and efficacy by avoiding steam pops and increasing confidence by creating effective lesions faster. It's safer too. Ablating at higher temperatures for shorter durations helps avoid damage to underlying healthy tissue. The system also uses less saline to cool the catheter tip, leading to a reduction in fluid overload complications. Most important to the leaders at the Texas Cardiac Arrhythmia Institute is the ability to provide better procedures and better care for patients. Let's listen to Dr. Andrea Natale, Executive Medical Director of the Texas Cardiac Arrhythmia Institute and National Medical Director of the Cardiac Electrophysiology at HCA Healthcare, and Dr. Rodney Horton, researcher at the Texas Cardiac Arrhythmia Institute, explain how the technology has improved care and workflow efficiency at their practice.
Every few years, frankly, every year, some company will come out and they'll say that they've got some latent great thing, and almost all of it ends up being nothing. And every 5 or 6 years, there'll be something, and we'll look at it and say, okay, this is improved, this is significant. And I think it was one of those. It was kind of one of those things where we had several iterations of improvement in ablation technology, open irrigation versus closed irrigation, and these other ways of getting deeper, more transmural lesions. But it would take signals that we would struggle to make the signals go away, and they would just melt away like butter. And that is something that we had really never seen using radiofrequency prior.
Every time we try a new technology, we go through a process of learning in how to optimize the best feature. But it was very obvious that the procedure was more efficient, even faster, because we can drive better power, better lesion quality, but with lower fluid administration. So clearly, for the patient and for us, is a more effective and efficient procedure.
It gives me direct feedback using temperature signals. Basically, it's color-coded. As the temperature at the tissue reaches 45 degrees centigrade, which is devitalized tissue, it turns red. And so it'll go from blue, which is cold, to orange, to yellow, to red. And so I actually follow it from a color standpoint. And so once it reaches the desired color, it sounds weird to say that, but then I come off. So my overall lesion time is a lot of times about 7 or 8 seconds, which is a lot shorter than what we would ordinarily use before. But it gives me that feedback very quickly and very visually that allows me to shorten the duration of the lesion.
I like to make sure that the temperature is red, which means 50 degrees for at least a good 10 seconds before I move. So it's one of the information that I like to have, and I think is very valuable. Besides, you can follow the direction of the catheter in three-dimensional geometry. That kind of help you to really reduce the amount of flow that you need to do the entire procedure.